Our talk is Core Data. It's Not So Scary, featuring Jonathan Lepolt. One time in a crowd full of developers, I yelled out Core Data just to see what would happen. A few people ran away, some looked at me and scoffed, others seemed confused but interested, and even fewer people gave me a nod and a smile. It was at that moment that I realized there were a lot of misconceptions about core data, and I wanted to clear them up. I've heard excuses like, core data is hard to understand and work with. Core data is antiquated and irrelevant. Core data doesn't integrate well with SwiftUI, and there are plenty of better third-party solutions out there for data persistence. It's misconceptions like these that are giving core data a bad name. In this talk, we'll build a sample iOS app from scratch using SwiftUI and Core Data. We'll utilize some basic but important features of the framework, demonstrating how to add, update, and delete objects. Hopefully together we can bust the myths surrounding core data and bring some attention to how great and useful this tool can be in your apps. When you wrote a long talk description, Jonathan. Okay, so bio. Jonathan is an iOS developer passionate about building cool stuff using great tech. I like theme parks and roller coasters and doing things outside with my family. My favorite drinks are bourbon, beer, and coffee, but not at the same time. All right, take it away whenever you're ready.
All right, I'm going to go ahead and start sharing my screen. This is where it starts to get fun, because I then get little pictures of you guys. So yeah, so I have some slides, and then we're going to build a little sample app together, and hopefully the live coding goes well. But yeah, so core data, it's not so scary. This topic comes up from time to time, and I always feel like people are really opinionated on one side or the other, and most people seem to really hate it. And I started trying to dig in to figure out why people hate it, and I didn't really get some great answers. And so I wanted to put together a talk and kind of I don't know, bust some of the myths surrounding core data. So a quick overview of the talk. We're going to talk about what is core data, are there any alternatives? Like I said, we're going to build a basic example app of how to use it. We're not going to be able to cover everything related to core data, so I'll have some call outs there, and then hopefully at the end we'll leave some time for some questions. So who am I? This is a shorter bio. I am an iOS developer at Atomic Robot. We're headquartered in Cincinnati, Ohio, USA, and I like roller coasters. First, let's start with a little joke, a little comic. It's one of my favorites. If you haven't seen this from XKCD, it's pretty good. So anyways, that sanitize your inputs. Okay, what is core data? Core data is actually just a representation of your data model. It can add data persistence to your apps. And here is a graphic that I just kind of stole from Apple documentation. So you can see that core data sits between the persistence layer and your application layer. Now, what isn't core data? Core data is not a core workout. It also has nothing to do with the Earth's core. But it's not actually the physical storage of your data. The backend store can be a SQLite database, but it doesn't have to be. It can also be XML. It can be an in-memory database, which we'll talk about a little bit, which is great for testing, but core data itself is not the physical layer, the physical storage. It's not a relational database. So we won't be thinking today in terms of tables, selects, joins, etc. That probably makes some people really happy and other people sad a little bit, but it makes me happy. So we're going to think more in terms of objects. Just a couple alternatives. User defaults is kind of the default go-to for persistence in your app. It's really easy to implement. It does not scale super well. It scales decently well, but not super great. You have all-in reads and writes, meaning you have to, if you have a list of something, you have to read the entire list into memory. And if you want to modify something in the list, you have to read the whole list, modify just that object, and then rewrite the entire list back out to user default. So That's not ideal if you're starting to deal with large data sets. There's definitely some third-party options. I've used Realm many years ago. I know there's still a following of that particular database. There might be some others, but these alternatives kind of make me grumpy. Very quickly, why do I like Core Data? I always am a big fan of first-party solutions. So in this case, this is provided by Apple out of the box. It integrates very nicely with both UIKit and SwiftUI. There are tons of examples in documentation. So inevitably, if you run into any issues, Stack Overflow is full of information there. The Apple documentation is really great. And then, of course, it just works. So I think Core Data is actually really great. Now let's build something. So what we're going to do, we're going to build an iOS app using Core Data. We're going to implement some basic CRUD operations so we can create, read, update, delete. I'm going to show you how to fetch data. We're going to build some relationships. And then, of course, we're going to cover unit testing because we care a lot about unit testing and it's really important. Before I jump into the code, do we have any questions up front? People are chatting. I'm not going to look at the chat, but I see the little.
Looks like, yeah. There's a question from Navati. Do we get to choose what is the backend store since it could be SQLite DB?
Yes, there's a few options that come out of the box. If you choose just the default implementation, it's going to be a SQLite database. But you can also use XML and the in-memory database, which I have no idea what that actually looks like. But there's a couple options for you.
All right, looks like that's the only question so far.
Cool. All right, so we're going to create a brand new Xcode project. And because I like roller coasters, we're going to create a roller coaster tracker. I'm going to build this in SwiftUI. I'm going to keep this box checked to use Core Data. It's going to set up some boilerplate code for us that is really nice and useful. And then I'm also going to include tests out of the box, just because we're going to circle back to that. This is good. We'll just keep all those defaults there. And here we go. So I'm going to make this bigger. I'm going to move this pane out of the way. We're not going to do any fancy previews. And then I'm going to make the font this big. How does that seem? Decent?
That looks good. Anyone need more bumping up?
And then I'm going to hide the people. And we're going to put them over here. Okay, so we'll just go through some of the files that Core Data created for us out of the box. Content view is our default view. We're not going to use this. We're going to delete this. We're going to delete this. And then our persistence layer. So this is really nice. This is what Xcode gives us out of the box. They call it a persistence controller. And I think that's a good enough name, but we don't need some of this code. This code is actually, I mentioned the in-memory database here. This is going to create your in-memory database for previews, and it's going to populate it with some items, but we're not using that. The persistent container is actually the kind of the physical storage, and then it's just doing some setup in the initialization. Everything we do is going to be done basically in the view context, which is kind of like an in-memory scratch pad. And so anytime we add an item or we make changes to an item, we're going to do it in this scratch pad, and it'll just remain there in memory until we save. And then here's our data model. I'm going to create a new entity. And if you want to think in terms of a relational database, an entity is basically a table. And so our first entity is going to be roller coaster. And then our attributes are kind of like our columns. And so I'm going to create two to start with. ID is going to be a UID, and name is going to be a string. And then both of these properties, I don't want to be optional. I want to make sure that when someone's creating a new item, a new object, that these values are present. There's some other options here. We'll talk about some of them in a little bit. So that's the deleted code. And now because I like to have my code, because I like to have my code organized, I'm going to create 2 new folders for views and view models. And I am going to use a rough implementation of MVVM, or model view model. It's just what I am most familiar with at this point, and I think it works fine for this demo. So we're going to create our first view. It's going to be roller coaster list view. And we'll create a view model while we're at it. And this is going to be an observable object, so that we can publish properties and get those changes over to SwiftUI. So first thing I want to do is come back over to our list view, and I am just going to build a pretty simple UI to add a button so we can create new roller coasters, and then we'll have a list of those. So add new roller coaster. I'm going to create a couple state variables. And then our view model is going to be a state object. And one thing that's really great about state objects is that they are only initialized one time for the entire lifetime of this particular view. So if you've used SwiftUI at all, you may have noticed that these views get initialized a whole bunch of times, but that's only so that it can rebuild the view. But in this case, if we have a state object, this initializer will only get called one time. Okay, so back to our view is adding, we're going to toggle that. It's in here. Okay, cool. Now we're gonna put a sheet up. So adding, and then that's just going to be a simple H stack that has a text field. Sorry. And we're going to bind that value to the name. And then another button to save. And then that's going to call a function that we haven't written yet on our view model, add roller coaster, pass it the name. And then we also want to reset some of our state properties so that the sheet will close automatically for us. False. Oh boy. False, and reset the name property as well. Okay, cool. So we'll come back over here to our view model, and we're going to need a reference to our persistence controller. I'm going to create a custom initializer here that is going to accept a persistence controller object, but we're going to default it to our shared instance. This is really useful for testing, which we will cover later. Persistence controller, okay, and then we're going to write our function. And roller coaster, it's going to take a name as a string. Okay. And now what we want to do is we're going to get a hold of that view context. So this is not a required step, but it's, if you use the context a lot, I find just creating a local copy of it, or a local reference inside a function really nice. So you'll see this a lot. It's on the container and the view context. Now all we need to do to create a new manage object is roller coaster. So one thing too that I want to mention about the data model, there's a lot of automatic code generation that happens, and so sometimes Xcode doesn't catch up, and so you can't see my NS manage object. So I'm just going to do a clean build real quick. and then a build, and then hopefully we can be off to the races. Yeah, okay, so roller coaster, and then we're gonna pass in a context here. And so now we have our NS manage object. So this is kind of our core data object. And if you remember, I mentioned the view context. So this is just in memory right now. Nothing's been persisted. So we want to set some properties here. This is just, whoops, this is just our UID. So we have an ID. Name is going to be the name that we passed in. And I'm also going to mention here that I'm not doing any data validation here. So we're just going to assume that the data we're working with right now is valid. Everything, just about everything that core data does needs to be wrapped in a try catch block. So we're going to do this a lot. And I also created a snippet. So as we write some more code, this will go a little quicker. NS error. And then I'm just going to throw an assert while we're debugging here. So just in case there's any errors, we catch them immediately. So error, saving new roller coaster. And then we'll print out the error. And then we'll print out some user info with the error.
So Jonathan, can we
Yes,
ask a couple of questions at this point?
of course. Let's do it.
Yeah, so Franklin has the question, is optional in core data the same as optional in Swift?
No, no. When it says optional in the data model, this is whether or not these properties are required when you create new objects. So if you are using an ID for your core data object, you probably always want to save with an ID. And in this case, name is going to be a really important part of our roller coaster. But if I had something like color, I might not care what the color of the roller coaster is. So I might leave that as an optional property. But in this case, these two properties are going to be required to save. And so if I were to try and save a roller coaster without one of these properties, core data would fail. It would not allow the save to happen.
Cool. And a couple more questions. Michaela is asking, why parse the error to an NS error?
I don't know. You get this user info dictionary. I read a book about core data, and they took this approach, and it seemed useful to me. I think really it's to get this user info dictionary off of it. The error contains some information, but the user info dictionary can contain some additional information that you might not just get from a standard Swift error.
Yep. And then Navadi is asking, can you give a quick refresher on what is a persistence controller again?
Yeah, the persistence controller is just kind of like just a controller or some sort of manager, and it's just going to be the bridge between core data and our application. So that's just, you could call this anything you want. This is the newer approach that I've noticed when you create new Xcode projects. It used to be called a core data stack. It's the same general idea, it just uses a different name. So that it's just in this case, we're just using it's a singleton because there's only going to be one copy of our core data database. So we just get the shared instance and do everything there. The container is the persistent store. So let's see, here is where it's getting the container, and it's just using the name of the roller coaster tracker, which is the out of the name box of the data model over here. Did that answer everyone's questions?
I think so. And also, in case some people might ask about this, and for clarification for me too, if you could explain what the context is.
Yeah, the view context is simply, it's just it's kind of like a scratch pad in memory for your data. So if you think of, I don't even know a good example. If you have like a chalkboard, that's kind of like but your chalkboard, you can erase and add new things, but then once you take a picture of it, that's kind of like when it's saved. So
Because you might want to do like a bunch of things to your data before you save it, right? So
yeah, the context is just, it's just the layer before the actual database, really. It's just you load things into memory, you can modify them in memory, but those changes won't be persisted until you save.
or as Navati said, it's like a temporary place before committing.
Yeah, I think that's reasonable.
Yeah.
I'm trying to think if there's a better way. I think I have some docs somewhere. We'll come back to that in this. I think there's some slides that talk a little bit more about that. But yeah, if you just think of it as like a scratch pad, so you can make all your changes to your data, as many as you want, add things, delete things, update things, but those changes won't be reflected in the actual physical storage until you save.
Cool. Yep.
Okay, cool.
Good now. Thanks.
Good. So, yep, no problem. So then back to add in a new object. So that's it. We've created it, we've modified it. And now the only thing we need to do is save our context. So that's it. Let's see if we're going to build failed because we don't have anything in our content view yet, but this is it. This is all you have to do to save. And then, like I said, pretty much everything in Core Data is going to throw. And so we just have to put a try in front of it and we're off to the races. So now I'm just going to create a simple tab view. And we're going to put our roller coaster list view inside it and make that a tab item, which is a label. Just create an image to make it look nice. Yeah, that's it. All right, so now we're going to run it and I'll show you kind of what it looks like. Oh, iPod 7th generation. Does anybody know why? This happens every single time I create a new project. It defaults to iPod Touch 7th generation. And every time it makes me really angry. And no one's been able to tell me why, what the significance of the iPod Touch 7th generation is. All right, still crickets, so nobody knows. All right, so it's running. Computer's chugging. Is Jeremy on the call? Jeremy, I need an M1 MacBook Pro. Okay, cool. And
yeah, those M1s are pretty great.
yeah, filled. Oh, whoops, I forgot. System name. Okay. But that's not important. So this is what we did. We put a button up here. I'm going to just create a couple roller coasters and save them. You've probably noticed a slight problem here, and that we're not actually displaying anything. There's no list here, but we can fix that. So let's come back over to our view model. And I'm going to create a new publish variable that is the list of roller coasters, and we're going to default that to an empty array. And then we're going to create a new function that is going to fetch our data. And then I'm going to get a hold of the context because I like to do that. And what we need to do now is we need to create a fetch request. And we can easily create a fetch request that will fetch types of roller coasters by just getting it directly off of the object type. Oops. And then we're going to sort it using an NS sort descriptor that is going to sort by roller coaster name, and we're going to make it ascending. And then we'll go ahead and set that on our fetch request. And sort descriptors takes an array. So if you want to sort by multiple things, you just pass the array. And then now all we need to do is fetch. Here. And fetch actually returns an array. And so we're just going to set our list equal to the results of the fetch. And we want to display them. So we'll create a list for each view model list roller coaster in, and then I'm just going to display the name of the roller coaster. This is something that I haven't taken the time to dig down, but even though these properties are not optional when you save an NS managed object, it actually is optional on the object, and I don't know why, and so I don't have a good answer for you, and I'm really sorry. So I'm just going to force unwrap everything for the sake of this demonstration. So please don't hold that against me. Also, don't hold the design aspect of this demo against me. I'm not out to try and win any awards. And we forgot one thing. We need to call the fetch method. And so now when our view model loads, we'll fetch the data. So there it is. So let's add some new roller coasters. And you probably noticed that our list is not automatically updating. And that's very sad, but we can fix that. We'll come back into our view model, and we're going to use a fetch results controller. Results controller, and that's an NS fetch results controller. When I add this, it's going to actually import core data into this file. We want to tell Xcode that we want to return type roller coaster. And then let controller equal. And then we're just going to populate some of this stuff. The good news here is we can reuse pretty much all of our fetch requests. So I'm just going to cut this, put it up here. The other thing to note with the NS fetch results controller is that a sort descriptor is required. So if you don't include a sort, it will crash. And so here we can just put our fetch request in there, pass our context in. Section name key path, we're going to come back to. Cache, I'm not going to talk about, but I can mention here that if you're making the same fetch over and over and over again, you can create a cache in your data model. And so Xcode is smart enough to not actually have to hit the database layer every single time. Controller, we need a delegate here. Oops, it's going to be self, and then return controller. It's object, because NS fetch results controller delegate is inherits from NS object. So then we need to call in it here. And then I will implement the delegate here. Controller content to change. This is the big thing on the delegate that gets called. So anytime the data in Xcode or in your core data model changes, this function will be called. And so we want a new method here. We'll call it refresh. And then, so now we just need to fetch. So fetch results controller dot perform fetch. Then our list is actually going to be the fetched objects, which returns an optional. So if we don't get anything back, we'll just return an empty list. And then similarly here.
Is now a good time for a couple more questions?
Oh man, if they're coming in, if they're pouring in, yeah.
Okay, so first of all, quite a few positive comments on your live coding.
Oh, thank you.
And let's see. Navati asked if you can give a live coding session on how to live code.
Okay, so I was on I was on the bench for a couple of weeks, and I built this app probably 15 or 20 times, and so persistence is the takeaway there, I think.
building muscle memory.
Yes.
The pun was totally intended, right? Persistence.
Yeah, I realized that. Yep, right here.
Nice. And let's see, Navadi asked, when you say cache, this is the local database cache, correct?
Yes.
Okay.
Yep. So I'm not going to do it, but if you come back into your object model, if you create, if you're doing a fetch request over and over and over again, is this what I want to do? No, I can't remember where the cache is, to be honest with you, right off the top of my head. And this is where the live coding fails. But in your data model somewhere here, you basically say that I'm going to use this fetch request over and over, like I'm fetching this list over and over and over again. So instead of actually telling Core Data to fetch that data every single time, you name it, you give it a name. And so then Core Data is smart enough to say, well, this data hasn't changed. We'll just give you the cached version of it.
And that's nice because, you know, that saves on performance too.
Exactly. Yep.
Yeah. And there's a couple requests for if you will share this code later.
Yes, it's on my GitHub, which is just my last name, Lepolt. It's up there. I'm sure Angie or somebody can send out the link too. But yeah,
post it.
Yep, it's out there. And I've got a bunch of different branches that we're about to get into, and so you can hopefully see piece by piece how we're going to build the rest of this branch.
Cool.
No,
right.
Jana.
We're good.
All right, cool. We good?
Yep.
All right, so same thing. We're just fetching the data, and then we've got a refresh that we'll call here, which actually we could just call refresh here. So now we'll run it again, and any changes that we make should show up right away. So let's see what's the piece, and there it's at the bottom, and it will also maintain the sort. So we're just sorting alphabetically right now, and so there we go. Cool. It's working. That makes me happy. So that's kind of the first step. So now I've got a couple more slides, and then we'll go into some slightly more advanced topics, if you will. Where's my cursor? I can't find it. Oh well. Okay, so yeah, just to touch on the persistence controller again, NS persistent container, or yeah, we talked about this. The container is, and this is just copied out of the docs. Sorry, the Zoom controller in my way. It's a container that encapsulates the core data stack in your app. And then we talked about the NS managed object contents. So again, from the docs, it's an object space to manipulate and track changes to your managed objects. Your managed objects are the core database objects that you're dealing with. So like I said, it's just a scratch pad for changes until you save. Okay, so there weren't very many slides there, but that's okay. Now we're going to jump over to a different project. So I'm going to do less live coding now and more showing you code that I've written before. So, and then I have a list of things. I want to make sure I didn't forget to do stuff. So this is almost the same code, but I already have some things set up. What we want to do, sorry, more Zoom controls in my way. We're going to add a new property on the roller coaster object that allows you to mark it as a favorite. But first, I want to talk about versioning your database. So anytime you make changes to a database, those of you that are familiar with relational databases know all about versioning, I'm sure. But I'm going to add a new version to my database. And we'll just call it V2. We're going to base it on the first version because everything is the same. And then I'm just going to add another entity. We're going to call it is, or another attribute. We're calling it is favorite, and that's a Boolean. And then what we want to do is we want to make sure that this is our current model version. So we'll come over here, and instead of version 1, we'll set it to version 2. And so now any managed object that we deal with has this new property on it. as far as migrations go, we're not going to talk about complex migrations, but Xcode is smart enough to migrate these database versions if they're simple. So in this case, it's going to be really simple. We're just adding a new attribute. And so Xcode's smart enough to say if an app opens up with version 1, we can easily migrate it to version 2, which is really nice. Let's see what is next on my list. So let's come back over to our view model. Oh, I've created another view. It's a details view, and it's simply right now, it's just going to show the name of the roller coaster, and then we'll create a button, and it will toggle whether or not this is a favorite. And then we want an image that is if the roller coaster is favorite, it'll be a heart that's filled, otherwise just a heart. And if we tap on it, it will call this toggle favorite. So I just had this in here so that we didn't try and run it. So now what we need to do is we need to just get a hold of our roller coaster object that's passed into this view model. So I'm going to do a guard let roller coaster. We'll get our context because we're going to use that. And now we're just simply going to get our is favorite property and toggle it. That's all we have to do to modify an object, and it's manage object. So now we just need to save, air saving roller coaster. The other thing I want to call out here is how I created the state object to inject data into it. So in this case, we need to pass the ID of the roller coaster. Yes, okay, so sorry. So here's the init on my view. So we pass in the ID, and then my roller coaster details view model, we pass in the ID. And then again, we're just going to pass in the default persistence controller. We're going to call fetch, which does pretty much the same thing as fetching the list, except we added a predicate, an NS predicate to it, which is basically just a filter. And we're just filtering based on ID, and we pass in the UID, and then again the results return an array, and in this case we only expect one object, so we're just going to set our current roller coaster object to the first result. And we're just double checking to make sure that we have set that correctly. So now we should be able to run, and this is a new app because the other live coding stuff went away. So we have to re-add some roller coasters here. We'll just add a few. If you have a favorite, feel free to shout it out. Okay. We forgot one other thing. In our details view, we need to wrap this in a navigation link. Destination is going to be the roller. Wait a minute. Yep, roller. Sorry, am I losing my mind? This is the wrong place. My fault. Back in the list view, sorry. Wrap this in the navigation link. It's going to go to our roller coaster details view. We're going to pass in the ID of the roller coaster. Again, we're going to force unwrap it. And then the label will just be, all right, so this should be good. So now if we tap on one of our roller coasters, it's going to open our details page with the name and this favorite button. So I'm going to favorite a couple of them. And this is just, you can see that it remembers, but I will rerun so that you can see that they're persisted. So Lightning Rod was not a favorite, but Magnum was. And Steel Vengeance was. So that's all we have to do to edit or update these items. You just modify the properties directly on your NS object and then just call save. Super easy. Any questions there? Now we're going to whip through the rest of these features. Okay, cool. So the next thing I want to talk about is deleting. So here's where these branches are all set up. And I'm going to write a unit test first. And we're going to test our delete functionality. And so this is how I've set up my test. So the persistence controller is going to use an in-memory store. And this is a good thing for unit testing because you don't want to touch your live database when you're testing. So in this case, all I've done is I've created a new roller coaster. I've saved it. I have fetched all the roller coasters, and I'm just making sure that there's one item in my results. And then I've created my view model, and I've passed in our persistence controller that's using an in-memory store. And then I'm calling delete. I've stubbed out a delete function, and I'm just passing in a particular index in our list, which in this case is 0. And then I'm going to fetch the results again, and I'm expecting there to be 0 after I delete. So if we run this test now, it's going to fail because we haven't implemented delete. So if you like test-driven development, this bit is for you. So it failed, which is expected. So now I've already done the hard work of writing out this code. And so this is pretty straightforward too. I pass in the index. This is our roller coaster list view model. So we just have a list of roller coasters. We're gonna get the item from the list, and then to delete, all we do is we get a reference to the context and we call delete on a specific object. Excuse me, and then we save. So if we come back to our tests and we run the tests succeed. And that's great because that means my code works. And then the last thing we want to do is we'll just implement it in the UI. So on delete, index set, and we'll call view model, delete the item at the first item in our set. And we'll run. And we can swipe and it's gone. And if we run our app again, we can see that they're gone. Any questions about deleting?
So I noticed that you set up that unit test for the in-memory.
Yes.
So is that just part of the core data API, or did you have to implement that in-memory part?
No, that's built into core data. It's when you set up your persist container. So here's the initializer. So our container by default is going to be our coaster tracker demo data model, which is over here. Whoops, over here. But if we pass in memory, it's and this is supported, even though it looks silly. It is manually setting our database to this location on the device, which is a temporary location that you can use. And so that's it. That's all you need to do.
That's pretty cool.
I was quite pleased. But yeah, it's great. It's fantastic for testing.
And going back to the delete, do you mind showing, did you have to do an add first before you do the delete for the unit test?
In the test?
Yeah.
Yeah, in the test I did. So I created a new object
Mm-hmm.
and I saved it. And then I already had, with a view model, we just passed in our persistent controller,
Mm-hmm.
the in-memory controller, because that's where we saved our object. And then we called delete on it and then just verified in the database that it was no longer there.
Cool. So I don't see any more questions right now.
All right, I'm going to try and whip through these next few. I've got a couple more things. I'm going to create a new entity, but first I'm going to create a new model version. We're just going to call it V3. It's going to be based on V2. And then we'll make sure we're using the latest. My entity is going to be a theme park, and it is going to have an ID and also a name. And then just like roller coaster, I don't want those to be optional. Now the fun part here, I'm not going to write any code, but the fun part here is the ability for SwiftUI views to use this special property wrapper. It's called a fetch request. And so if you pass in your managed object context, which we did way back in our app code. So when we created our content view, we passed in the managed object context that we've created, our shared instance of it. And so any child view of or descendant of content view can access this environment variable. And so we did that in our theme park list view, which is new. So we have access to the view context. And then we just created a fetch request, which automatically uses our context. And that's going to fetch all the theme parks that we've created. And then you just loop over everything the same. And then I created an add function that is going to be very similar to adding the roller coaster. It's the same sort of thing. So Xcode might yell at me because I updated the database, but looks like we're good. So now we have a theme park tab, Kings Island. The other thing that's nice about using the property wrapper is that it automatically keeps everything up to date. So
It looks
I
like
think
we
that's
have
pretty sweet.
a couple more questions.
Sure.
Would you recommend using core data as a network caching mechanism?
I have never considered doing that. So I don't know that I'm a good person to ask for that, but is that Adam? If that's Adam, tell him he can
Oh,
get off
that's
the call.
Navati.
Oh, okay.
To
Adam might
elaborate.
have some context. Adam might have some context to add about network caching, but yeah, I don't know. I never really considered doing that. I guess if you're trying to store anything locally on your device, I think core data is a pretty reasonable solution. That's my best answer.
And then Michaela has a question on, do you have to do database migration when things change? Like when you change the model later on, like adding properties to an entity after the app has already shipped?
If there's simple changes, Xcode is smart enough to do automatic migrations. Even changing data types can be automatic. But if it's a complicated, like if you're taking, if you're like splitting an entity into like two different entities, there's ways that you can map that data using the XC data model. I'm not going to get into that. You would, where is that? I think actually, I don't even remember. There's a way to add maps. Actually, you might have to add a new file type. It's a new file type where you add a map, data mapping. But that's the advanced course. But the takeaway that I wanted to show you, and I don't know why Xcode is throwing these errors, it shouldn't be because obviously it built fine. There we go. The takeaway here is that we built this whole thing without needing a view model and without using the fetch results controller or anything like that. It's all just baked right into SwiftUI, which is super nice.
Yeah, that fetch request modifier is pretty cool.
Yeah. All right, and then there's, which I think I was supposed to go back to some slides here at some point. Ready to this. Oh wait, no, here we go. Yeah, NS fetch request. So this is again from the docs. It's just what you're searching for in the database. The fetch results controller. I don't know why this is coming afterwards. I think I skipped over these slides. You guys are good at this stuff. Predicate, it's a filter. Fetch request, this is the property wrapper for for using the manage object context. Okay, and then there's one more fun piece that I want to show you. It's with grouping. And we're going to create another new model version just because it's good practice to do that every time you're changing your data model. And I'm going to add a relationship after I change my default. So we have roller coasters and we have theme parks, but wouldn't it be nice if we could add a roller coaster to a theme park? That's not a rhetorical question. Yes, it would be nice. Very nice. In fact, so nice, we're going to do it. So what I've done is I've created a relationship. Sorry, I guess I should have talked about this a bit more. I created this relationship in my roller coaster entity that's a relationship to a theme park. So I named it, and then you choose a destination type. And then back over in theme park, I've created a relationship that I'm going to call roller coasters. Note the S. It's important. And the destination is roller coaster. And then the inverse of that relationship is going to be a theme park. And then I want this relationship to be too many, meaning many roller coasters can belong to a single theme park. But in this case, a roller coaster can only belong to one theme park. And excuse me, I think I already have everything set up so that we can just run this. Oh, I probably should show you some code first. I created another new view that I'm calling coasters by theme park view. And so basically what it's going to do is it's going to group roller coasters by the theme park that they belong to. So everything is, there's not too much crazy stuff going on here. We're still using an NS fetch results controller. The difference here is that I'm using this section named key path. And I'm passing in the theme park name, but that's on my roller coaster. So what this is going to do is it's going to group the results by the name of the theme park that the roller coaster belongs to. The fetching data is all the same. The only difference in the refresh is that I'm creating a dictionary, and I'm organizing these things by theme park. So theme park is going to be my key, and it's going to contain a list of roller coasters.
So Jonathan, just a heads up, we're at the hour.
Yep.
And people are welcome to drop off if they need to, but just give you a heads up. And we have a couple of questions if you can still take them. See, Michaela's asking about versioning the data model. What does that do?
It creates a new definition of what your data model looks like. So, I mean, you can go through the original version. So this is, I think this is actually stored like in XML in the project. So here's what version 1 looks like. So if you picture this snapshot, this is what your database looks like. This is what it looks like in version 2. This is what it looks like in version 3. So it's just, it keeps a snapshot of what your database, what the structure of your database look like.
Right. And Adam's asking, let's say you have a project with lots of branches. If you switch from branch A to branch B, where branch B is back in time, how does core data manage those potential migrations that might happen?
It might crash. Your app might crash. But if you're developing locally, like that's kind of just something that you need to be aware of. Because once the data is stored in your app, if you go back in time or create new entities, like it can't, if it can't automatically migrate it, it's going to throw up on you. So that's just something to keep in mind. Or if you're in active development and you're adding new types or changing types, like a lot of times people will just delete the app, right? Delete your app and then start over if you're in active development. But yeah, before you release, you want to make sure that those migrations are successful.
And I guess as a follow-up, when you fetch data, how does core data know which version of the data model you're using?
It's we set the current version over here. So you just choose the current version, which is probably usually going to be the most recent. But if I don't want to change branches right this second, but if I were to change branches, it would, you know, it would change the current version. Okay, so real quick, I'm just going to add these roller coasters to theme parks and then show you what that looks like grouped. So that was it. That was easy enough. And if I let's see, if I add a new roller coaster piece, and then I'm going to add it to Kings Island. And if I come back over to my group list, you can see that it's updated. It's updated everything. So pretty sweet. So that's the code. I just have a couple more slides and we'll whip through these things, and then that'll be pretty much it. So I just want to touch very briefly on relationships. So I pointed out they can be one-to-one, one-to-many, and we used a section named key path to group our results by a particular attribute. Then just a quick summary. So what did we do? We were able to add, update, delete, manage objects from a core data database. We used 3 different methods of fetching data and displaying a list. We added a relationship between 2 core data entities. We wrote some unit tests, and you were subjected to a couple dumb jokes. And then just real quick, what did we not do? We talked about complex migrations, but I didn't go over them in detail. We didn't talk about CloudKit, which is Apple's cloud version of a core data database. We didn't talk about background processing. The important takeaway here is that if you are using NS managed objects, you have to use them on the same thread in which they were fetched. Otherwise, you'll get a crash. We didn't talk about storing custom types in a core database, which you can do. And we didn't talk about the undo redo stack that core data gives you. So there's a lot of stuff that you can do that we just didn't have time to cover today. That's it. That's the end of the talk. So I don't know if there were any additional questions or if anyone has any rotten tomatoes they've been saving.
Well, this was a really great presentation. Yeah, I mean, you covered a lot, and the whole CRUD, database operations. It was pretty good at too. So yeah, lots of comments, positive comments pouring in. Yeah, that at fetch request, I need to dig into that a little bit more. I haven't heard about that one before, but that could come in really handy.
Yes, that is, especially if you're using SwiftUI and you're not doing anything complicated, you're just maybe fetching and displaying the data. Super nice. That was here.
Yeah, that
Yep.
was cool.
And then it even gives you sort descriptors, which are not NS sort descriptors. They're just sort descriptors, but you can pass in a couple different sorts. It is a little limiting, but if you're not doing anything crazy, it's pretty nice.
All right, any last questions? Anyone? Yeah, thanks so much, Jonathan. That was really great.
Sure. Yeah, and all this stuff is up on my GitHub. I forget what I called it. Coaster Tracker demo.
Yeah, I posted
it's up
the
there.
link,
Oh,
early.
cool.
Yeah.
Yep, it's all up there. There's a bunch of different branches. Main and final, I think, are identical. They have just all the final source code that we went over today. I will try to go through and add comments to things to hopefully add some context there.
And can I post your repo on the meetup page too?
Yeah, you can. Yeah, that's all public. I don't care where that goes.
Okay.
Submit
Yeah,
a PR. If you find any bugs, submit a PR.
cool. Yeah, and this talk is recorded, so if anyone wants to review it later, it's on the Cocoa Heads YouTube channel, or will be in a bit. So, all right. Well, thanks everyone for joining us. And yeah, if there are no other questions, hope to see you next month.